Hello, ladies and gentlemen. Today we're going to be doing skill 44, which is finding a tangent line related to a differential equation. And what this really is, when we're thinking about tangent line, we think about point slope form. So point slope form is just simply y minus y1 equals to m times x minus x1, where m is our slope from our differential equation. And I'm just going to abbreviate that as diff EQ. And then x1 and y1 is our initial condition. And there's going to be a mixture of problems that are just concrete x and y situations. And then there's going to be some problems that are not x and y situations that kind of have dependent and independent variables. So what this is our independent. And then our y is our dependent variable. All right. So the good news is on these, there's very concrete steps to doing this. So the first thing that you're going to do is you're going to find the slope from the differential equation. So this is where you plug in the initial condition to find that slope. And what I mean by that is just simply your x and y coordinate. And you are given the x and y coordinate in these problems. Then you want to kind of use point slope form to come up with a general equation for the approximation. And what we do essentially is that we move that y1 to the other side. And this gives us our linear approximation. So let's actually take a look at one now. All right, so this first question here, consider the differential equation to always be given a differential equation with a particular solution having an initial condition of y of 1 equals 0. So I'm going to circle this and I'm going to write this as my initial condition. Use the equation of a line tangent at 1, 0 to approximate the value of f of 1.2. So our x is going to be 1.2, and this is going to be our x1 and our y1. So I'm just going to do dy of dx, plugging in the point 1, 0. So what that means is I'm going to plug in 0 for my y. And I'm going to plug in for my x 1. So this is just going to give me 1 over 1. So my slope is going to be 1. Then I'm going to write my equation y minus y1 equals to m times x minus x1. And we might as well just get that y1 moved to the other side. And fortunately, it's asking us for what is f of 1.2. So that is the thing that I want to solve for. My slope is 1. So I got that from just plugging in my x and y coordinate into the derivative. And then my x is just 1.2. So I'm going to plug in a 1.2. And my x1, which is my initial condition, is just going to be 1. And then my y1 is going to be 0. And I'm just going to get a number. So this is just 1 times 0.2. So that is going to be 0.2 as my final answer. All right, let's look at kind of an application problem type of scenario. This is example 2. So some of these are not going to be like X and Y coordinates explicitly, but it really is the same idea. So first thing that I would do is I would find my initial condition. So my initial condition is 1, 70. And what this is kind of telling me here is that the t value, which is my independent variable, is 1. And then this is my h of t1. And I'm just going to call this t1 for my initial time. And then it's asking us to find and estimate the value at t's of 0.8. So we want to find h of 0.8. All right, like before, I'm going to find my slope. So that's the first step. So dh dt of 1, 70. Now notice here I have t and I have h of t. Notice there is not t in my formula, there's just h. So I'm just going to plug in the value of h, which is 70. And my slope is going to be -7. All right, then what I'm going to do is I want to be able to find h of 0.8. So one thing that I can do to kind of customize this situation is I could say that I have h of t minus h of t1 equals to my slope. So I'm just going to call that m times t's of t minus t's of 1. And if I want to actually find h of t and come up with a general equation, that would be equal to m of times t minus t1 plus h of t1. And if I want to find h of 0.8, what that means is that my slope is -7. My t is going to be 0.8 minus 1. And then my h of t1, this is just my initial condition here. This is just h of 1. And you don't have to do this step. But the step that I do like to see here, I'm just going to kind of clean this up. Net 0.8 minus 1 is -0.2. And then h of 1 is 70. So that's my initial condition. So then I got 7 times 0.2, or -7 times -0.2. And that's 1.4. So I'm going to say that h of 0.8 equals to 1.4 plus 70 for a total of 71.4. So basically you are using just your point slope form. If you want to do it a little bit more crude, you could write this as y minus y1 equals to m times x minus x1, knowing that x's and t's kind of mean one and the same thing. So my initial condition here is y minus 70 equals to our slope, which we found to be -7. And then my x would be the 0.8 minus 1. And I would actually get the same thing. So if I actually did -7 times 0.8 minus 1, this way is just a little bit more crude. Plus 70, I would also get the 71.4. So with that, that is skill 44.